Let's get some extra practice on a problem just like example 3. Here's example 4. It says Roland received a score of 70 on a test for which the mean score was 65.5. Roland has learned that his z-score of his test was 0.6. What is the standard deviation for this set of test scores? So again, we have 4 things in the formula. We have the data, we have the mean, we have the standard deviation, and we have that z-score. Then the formula is always z-score equals data minus the mean over the standard deviation. Okay, let's give it a read. Received a 70 on the test, so that's my data value. A mean was 65.5, 65.5, and then it says the z-score was 0.6. So the z-score was 0.6. So it seems to me we don't have the standard deviation. So let's plug this into the formula and see what we'd have. Well, z-score was 0.6 equals data was 70 minus the mean, which was 65.5, divided by the standard deviation. I don't know what it is. We can give it any letter that we want. I'm going to go ahead and give it, I don't know if this is a population, so I'll just call it S for standard deviation. Okay, it could have made it X. I just don't want you to get mixed up with the X is the data value here. Okay, so that's an S. Just make sure you know that's an S, not a 5. So what do I need to do? Well, I need to solve this. So I'm going to multiply both sides by S. If I multiply both sides by S, I'm going to have 0.6s on the left-hand side. On the right-hand side, the s's cancel. I'm left with 70 minus 65.5, which is 4.5. I divide both sides by 0.6, and I end up with s equals 7.5. So, what was the standard deviation of test scores? 7.5 was the standard deviation of those test scores. Okay. So this next one's really fun to ask in class because students get it wrong all of the time. And I mean all of the time. Okay? So what's the idea here? It's about percentiles, and it says most standardized examinations provide scores in terms of percentiles, which are as follows. So if you ask your score, yeah, they can give you the score, but what's more important is the percentile. So I always ask students in class when I'm teaching this, would you rather be in the 10th percentile or in the 90th percentile? And almost always, students in their mind have this backwards. Most people would say, well, if it's a test score and I'm trying to get into the university or something like that, say, I want to be in that 10th percentile, thinking that that means I'm in the top 10%. Well, it's the exact opposite. When you say a percentile, if you're in the 10th percentile, that means you have scored in the bottom 10%, meaning you have scored better than 10% of the people, not 90% of the people, which you originally thought. So the percentile is the number in which you have scored better than that many people. So if you're in the 10th percentile, you've only scored better than 10% of the population, versus the 90th percentile, you have scored better than 90% of the population. So you would much rather be in the 90th percentile than in the 10th percentile. So just remember, a percentile is you have scored better than that many data values, or that percent of data values are less than X. And that's what it says in that next part right there. It says the p percentile is p% of the data values are less than X. Okay? So let's look at this. It says in a recent year, the median salary for physical therapists was $74,480. If the 90th percentile for the annual salary of a physical therapist was $105,900, there's an extra zero there, so please get rid of that extra zero. Okay, $105,900. It says find the percent of physical therapists whose annual salary was A, more than $74,480, B, less than $105,900, and C, between $74,480 and $105,900. Okay, so I'm a very visual person here. Let's just kind of get a graph out and see what the heck is going on here. We know that the median was 74,480. And I want to really emphasize the fact that this says median, Because what do we know about median? Median is not the average. Median is the dead center. That means it's in the middle of the data. It is the 50th percentile. So 50% of the people make below 74,480 and 50% of the people make above 74,480. Okay? It says if the 90th percentile for the annual salaries was 105, so I'm going to put that over here, 105,900. That's the 90th percentile. That means 90% of the people scored below that, okay? So what do I know? I know 50% are in this block right here. And then if that top block's 90%, then I know that 40% have to be in the block between 74,480 and 105,590. All I did for that was the 90% minus the 50% gave me the 40% in between. Okay. If there's 40% between, what does that leave above the 90%? Well, above 90%, that's going to give us our 10%. Again, how am I getting that? Well, just do 100 minus 90. That gives me my 10%. So let's look at these questions right here. It says, how many scored, or how many made more than 74,480? So if you think of the 74,480, if that's the 50% mark, how many scored more than that? Well, that would also be 50%. There's 50% above and 50% below. So what percentage? 50% scored or made above 74,480. How about less than 105,900? Well, that is the 90th percentile. 90th percentile. So that tells me by definition that 90% scored below. That one's super easy. Okay. And then how about the between 74,480 and the 105,900? That's where we did the 90% minus the 50%. We already figured that out, which was 40%. So how many scored below? The answer was 40%. Okay?